Assalamu alaikum. Today's topic is mass spectrometry. Mass spectrometry is a technique which is used for different purposes. It is used for number one, detection of isotopes in a given sample. Second, determination of atomic mass of isotopes in a given sample. Third, determination of natural abundance of isotopes in a given sample. Natural abundance means how much percent of each isotope is present in the sample. Number four, determination of molecular weight of compounds. Number five, determination of molecular formula of compounds. And differentiating between compounds which have nearly same molecular weight. For example, C3H8O, C2H8N2, C2H4O2 and CH4N2O all have the same molecular weight, which is approximately 60 atomic mass units. And number 6, we can study the fragmentation patterns of a compound during the thermal cracking process. Many Nobel Prizes were awarded to scientists working in the field of mass spectroscopy. Many Nobel Prizes were awarded to different scientists in the field of mass spectrometry. The details are as under. J.J. Thomson was awarded Nobel Prize in Physics in 1906 for his work on theoretical and experimental investigation on the conduction of electricity through gases. F.W. Aston was awarded Nobel Prize in Chemistry in 1922 for the discovery of isotopes in large number of non-radioactive elements by using mass spectrograph. F.W. Aston was the first person who separated the isotopes of neon, and he found that a sample of neon has three isotopes, neon 1020, 1021 and 1022, by using mass spectrograph, and large number of other isotopes were also detected. W. Paul of Physics in 1989 was awarded Nobel Prize in 1989 for the development of ion trap techniques. J. B. Fenn and K. Tanaka, most recently in chemistry in 2002, they were awarded Nobel Prize in 2002, which is the most recent one, for introducing soft desorption ionization methods for mass spectrometric analysis of biological macromolecules. The main components of mass spectrometer can be diagrammatically shown as follows. It consists of a sample inlet, or it is also known as vaporizer. It vaporizes the sample. The second part is known as ionization chamber. Different type of ionization chambers are used. The third part is a uniform magnetic field. The fourth part is detector. And then there is amplifier, and the last part is known as oscillograph recorder. First of all, the sample is vaporized by the vaporizer, and this sample inlet, it introduces the sample into the ionization chamber. Let us suppose we have a sample consisting of 3 isotopes having different masses M1, M2 and M3, having different isotopes. The function of sample inlet is that the sample is present at atmospheric conditions, that is, it is present at a pressure of 1 atmosphere. It introduces the sample into the ionization chamber where the pressure is few millimeter of mercury. In the ionization chamber, the sample is converted into ions. When the sample passes through ionization chamber, all the isotopic atoms, they are ionized by the loss of electrons, and we get positive ions having different mass to charge ratio, having different m by z value. Now the vaporized sample is then introduced into the magnetic field. It is still lower pressure, which is a few micrometer of mercury. The ions, according to their mass to charge ratio, are deflected at different angles and are detected by the detector. These ions which are detected by the detector are converted into electronic signals, and these electronic signals, they are amplified by the amplifier and taken to oscillograph recorder. The oscillograph recorder record the signals in the form of a graph. This graph is between the intensity of the ions or number of ions of a particular mass and the m by z value. The graph which is obtained from oscillograph recorder is known as mass spectrograph. Let us suppose if we have a mass spectrograph, for example, we have a mass spectrograph for a sample and it produces 3 peaks. Now if we move from the peak towards downward direction, we get the mass of the isotopes. If we move from the peak towards vertical axis, we get the natural abundance of isotope. And the number of peaks, they show the number of isotopes or number of different fragments which are present in a sample. Thus the number of peaks give the number of isotopes or number of different fragments with different molecular weights. If we move downward, we get the relative atomic mass of isotopes or the molecular weight of the fragments, and if we move vertically, we get the number of atoms or number of molecules having that particular atomic weight or molecular weight. Allah Hafiz.